proof is usually one of the hardest things in the geometry year. And if you've talked to any of your friends, they'll say, oh my goodness, proofs are so hard. They're not that bad, honestly, if you follow along and put some logic together. Let me show you a couple of things. First of all, one of the ways to organize a proof is what we call a two-column proof. You can see it here on the right. So you have two columns which represent kind of this side. There's the one column, and here's the other side over here. Now on the left side, we have what we call our statement side. This is where you're going to put the things that you notice or see, the things that are connected by your logic. So on this side, you're going to list things that you know and see. You're going to connect your logic there. On the other side, you're going to put the reason for knowing why you know that. So once you've given a statement, you've got to give the reason. And if you give a statement, you got to give the reason, and so on. You will back up everything. You've got to back up every one of these with a reason on the other side. You can't just say because it's so or because I saw it, those kinds of things. Other things to notice is that they have provided us, usually, is with a given. Now the given can be as simple as some angles or some sides. It can be a diagram to help you to know what it would look like. So the given is very important to us, and it's basically, without giving too much away, it's just the starting place. Usually, the very beginning part of a proof is you just putting down what the givens were, and the reason is, hey, you gave it to me. That's a nice way to start a proof. Now, also, you'll notice that this style of proof provides you with what they call the prove area. Think of once the statements have all been made and you're connecting them, you're trying to get to the proof idea. And so that would be where you would finish. So the nice thing about a proof is in a two-column format is it'll tell you where to start, it'll tell you when you're done, and usually will provide you some information. And the two-column format will let you give a statement and a reason, statement and a reason, statement and a reason, until your final statement will be the thing that they want you to prove. You'll say, well, I know these are congruent, and you'll then say why that's congruent. Now, the proofs that you'll be working on will be focused on the use of this idea of triangle congruence. You've already established the 5 ways to know when something is or isn't congruent, a triangle is or isn't congruent. But these 5 things will definitely be important to seeing it. Now, I want to give you a couple of hints, and I cannot tell you, pay attention here to these hints. This will make proof making and doing very simple. You watch. So, one of them is start with the givens and restate them. Don't shorten them up, don't change them, don't interpret them, just restate those givens. Second, when you're looking for more sides or angles in trying to find one of these to happen, here are the places to look, at least for now. Look for common sides. What a common side refers to is if you had a triangle and it had a side that was in common in both of them. So for instance, in this little diagram here, this guy right here is in common to both. And that, of course, would mean that it's congruent in both of those guys. So keep an eye out for that. The second guy to keep an eye out to look for is vertical angles. Vertical angles are found in lots of diagrams as well. So if we had a diagram like this, and they were talking about angles or triangles, you could say that these 2 angles are congruent because they are vertical to each other. And we know that vertical angles are always equal. So, quick tip, did you catch it? When you're doing things, look for common sides. That's a free side of information. Look for vertical angles. Those are some free information about vertical angles. If you find vertical angles, state that they're vertical and then state vertical angles are equal. What I'm doing here is I'm telling you what to state, So this would be my statement, and then what would be your reason? So this is your statement, and then the reason that would follow. Vertical angles are equal. If you find a common side, you would say something like, well, this is equal to itself. So that's how you would write a common side. So if this guy was GH here, you would say GH is congruent to GH, like this. That's your statement. And then the following reason is the reflexive property. Now that's new to you, but that's why I'm teaching it to you. Once you have found all of the information that you feel you need for one of these 5 to happen, when you found 3 sides or an angle, side angle, and so on, then what you do in your line there basically is you're going to say, well, I know this is congruent to this. That would be your statement, right? There's your statement. And then the reason that would follow would be one of these things that you actually saw. So let's put this into practice. So the given information sits right here. And as I mentioned to you, this is where you start. So let's start by stating the given. Angle B is congruent to angle E. I can put this both on the same line, or I could put it on 2 different lines. I think I can fit it in here. And the reason's the same. They were both given. This is your starting place. It's a freebie, right? And I would always suggest put that on your diagram. So angle B would be down in this corner. E is in this upper corner, so I have one angle. And they tell me CB, which is here, and DE. So I actually have 2 pieces of information. Now, this is where we go searching, and I gave you some tips. Look for vertical angles, look for common sides. There'll be other things to look for, but I definitely see these 2 vertical angles that have to be equal. So I have to actually make that statement. I have to say that's what I actually saw. So that would be angle EAD, angle EAD is congruent to angle BAC. And I mentioned the way you write that is vertical angles are congruent. So I actually think I have enough information. Let's take a look if you think so. I have an angle, and then a side. I have an angle, and then a side. So I do have enough information to make this statement. So I'm going to say triangle EAD has to be congruent to triangle BAC by angle, side. Or if you read it the other way, it would be side, angle. This is our very first proof. We started with our given. We made logical conclusions and backed them up with reasons. And then we brought it home by giving what the final proof wanted to be. One more clue about success with a proof is that if there are words used in the given statement, like if they mention midpoint or bisector or perpendicular or linear pair, anything that has words in it, you would use the definition to translate those words. Let me give you an example. If the given statement was that C is the midpoint of GH, that's our given, notice what I had to do next in my proof. Next, I say, well, what that means, the translation of that, is that the 2 pieces would be equal, and it's based on the definition, right? Because if I tell you, here's GH, that C is the midpoint of that, then of course, yes, the conclusion would be that GC equals CH. I'm putting a star by that. If you have any givens that use words, then you need to go one more line over and provide what that means mathematically, and you almost always use the definition of that. So it might be the definition of the midpoint, but it might be a definition of a bisector or a perpendicular or linear pair. It would be always the definition of that word that translates it out. Let's quickly do one last example. Here are our givens. So again, quickly, we put in our given. Angle C, congruent to angle E. That was given. And you want to show what you know. I know that that is the same as this. Angle CBD is congruent to angle EDB. That is CBD here and here. And that was also given. Notice I'm starting where they told me to start with my givens. Next, I need to find something on my own, and I notice that there's a BD right here that is in both triangles. So I could say segment BD is congruent to segment BD. We call that the reflexive property. And that describes the relationship of those being equal. Now let's take a look if we know enough. We do. I think we have angle, angle, side, angle, angle, side. So we can bring this home by saying triangle BDC is actually congruent to DBE by angle, angle, side, or sometimes side, angle, angle. So this is the idea. Get your givens. Go find me something. When you find me something, always give a reason for it, and then bring it home with what they actually requested in the proof. Remembering, as I gave you, if anything in the given has words, always translate it using the definition of that item.